Engine Performance Expo viewers. Welcome back. Again, Lake Speed Jr. Got a special guest with me here. We're at Driven Racing Oil, Bill Alexander. And obviously, people who know my background know that I have a little bit of history here at Driven.
Yes, you do.
But what they may not know is that me and Bill share something in common besides wearing black t-shirts and khaki pants. Bill is also a certified lubrication specialist and tribology kind of guy like myself, so kind of brothers from another mother, right?
Yeah, we are. And this is great to finally meet you because here I am and picking up kind of and moving forward with Driven, and you are driven.
I was. You're driven now, so it's all good. Yeah. So we're here because of our common shared background and understanding of all things lubrication related. We figured we'd give you guys a little tech tip today.
Yeah.
The 3 things that every car guy and every car girl, because there's lots of car girls out there too,
absolutely,
should know about motor oil.
Motor oil.
Because thank you to the internet, there is gobs of myths and misunderstandings about motor oil that people don't understand. So we're going to knock down 3 things today that people typically don't understand the basics of. They kind of miss. And I'm sure, Bill, you probably get these emails and calls.
We do.
Every day.
We do. And I think one of the things we could start off with is conventional versus synthetic. And now that's a big topic. I understand.
That's a video by itself.
It is, absolutely. But we do get that. Is a synthetic oil better than a conventional? Or is a semi-synthetic better than a conventional?
Right.
You know, all of those different types. So I think one of the things that I think you and I talk about a lot, and I think we'll continue to talk about, is application. It's using the right oil in the right application.
Yeah, application dictates chemistry. Right. That has been my mantra forever.
Forever.
It always holds true, by the way.
It does. And so we get a lot, should I use your synthetic oil versus, should I use a mineral oil? Mm-hmm. Well, it depends on the applications. When you look at it, a synthetic oil is great if you're going to put it in your car and go 10,000 miles. Mm-hmm. And provided you have the right filtration. But if that's your goal, a synthetic could be great. But would a synthetic work well in a racing application? Mm-hmm. Where maybe you're going to use it one time or you're going to do one lap. If you're kind of that average person out there, do we want to spend the money on synthetic? So we get that question a lot.
Of course. And what I think what it kind of misses on is they focus on that synthetic versus conventional.
Correct.
And they miss the fact that really what they should be thinking about is viscosity, because it is the most important aspect of any lubricant.
Absolutely.
And so, again, application is going to dictate this.
Viscosity.
Correct. And then people sometimes get a little bit confused about the zinc deal, so we'll cover that later. Yeah. And then we're also talking about additives, because once you're talking about zinc, then you kind of, next thing is, hey, you go to AutoZone or Walmart or wherever, there's a whole wall of mystery fix-all cures, that's where the old snake oil thing comes from. So we're going to address these 3 things. So back to the synthetic versus conventional, let's talk about viscosity. What are the things that you see that people miss and misunderstand the most about viscosity?
It probably in my career, what I've seen the most is that the 10W or the 5W, the W. Okay.
Wait. Okay. By the way, tell them, Bill, is there such thing as weight in motor oil?
There's not. It's
shocking.
It's actually winter. The 5W, the 10W stands for winter, and what that tells you is that this motor oil is a multi-grade. So that's important to know.
So we'll draw it out here so people know.
Yeah.
Think about a 5W, say 30.
Sure.
This stands for winter, not weight, winter.
And what we're talking about here is the low temperature performance of this oil.
Let's draw a line, right? Let's cut it, because really we're talking about a multi-viscosity oil. Now, that doesn't mean that the oil has 2 different viscosities.
Nope. It just means that this oil will move between these viscosities as needed based on the temperature.
So we'll put winter there.
Cold.
Because this is cold cranking, right?
Yep.
So this is your cold viscosity, and then this is your hot viscosity. Now wait, here's the thing. How can an oil go from a 5 to a 30? Because we know that oil gets thinner as it gets hotter. It doesn't get thicker, so that looks like it's counterintuitive. Bill, please explain.
Well, what we're going to do is we're going to use an additive, and we'll kind of go back to that, called a viscosity improver, or a viscosity modifier. And what that is a polymer, and what that polymer does is when it's cold, it shrinks up, and when it gets hot, it expands. You're in Minnesota, and it's negative 30 degrees, and you get up in the morning and you start your car, you don't want it to be a 30 weight.
Right.
You want it to crank, don't you?
Yeah.
So we need that oil to come over here because it's so cold outside and crank. Because if you can't turn your crankshaft, you're not going to start your car.
And that's the key. So that 5W really isn't the same measurement as this.
No.
And that's where people miss. Is that they think that, okay, it's a 5 that becomes a 30. Well, no. These are two different measurements.
Correct. This is your measurement at 100 degrees C, or what we would call the operating temperature. Once your engine gets up to its operating temperature.
So this is flow, actually.
Yep.
Measured in an orifice, point A to point B.
Right. At a temperature of 100 degrees C.
Right, so we'll do 100 C here. Right, that's this number, hot, and that's the flow.
Correct.
Okay? So explain what this is.
So what we do to measure this, we use what's called cold crank.
Right.
And so what we do is we take the oil and we put it in a machine and we get it cold. And we see, can we crank it? It's the cranking, it's the spinning.
Right.
It's the
So this is returning it.
Yep.
So you're measuring that rotational
force.
Kind of like that crankshaft turning over.
Exactly.
So this is turning, this is flowing. They're completely different.
Right.
Oh, and by the way, with a 5W is what, negative 25 or negative 30?
Yeah.
Yeah, we'll just call it negative 25 in round numbers.
Yeah.
C. So the temperature is slightly different.
Exactly.
So that's the thing, is that this is how we measure the viscosity cold for cold cranking.
Right.
This is hot. So the idea is the colder the operating temperature outside, the more important this number becomes.
Absolutely, because where does wear occur the most?
Startup.
So if you're too heavy, or what if you just had a monograde? So if you just had a straight 30 weight, it's a 30 weight.
Yep.
If it's cold, it's thick. It thins out as it gets warmer. So that's why you can go back to the days.
It's too cold, essentially, right? It's too thick. It's too thick to crank. Yeah.
So there you go. So that allows our oil to operate in the application, which is a vehicle that sits outside. You know, one of the things sometimes I talk about this, if you go to an industrial plant, an industrial facility, all that machinery is inside. So they use a lot of monogrades. It never gets cold or warm. It stays kind of a normal ambient temperature. But in motor oil, we definitely want to have something because cars operate in all kinds of environments.
Well, thinking about your snowmobile guys.
Right, exactly.
ATV guys, where you're going to drive them in the winter, you're going to drive them in the summer, you need to have that multi-grade oil. You need to have those viscosity modifiers and the base oils. And that's one thing back to the synthetic versus mineral. The synthetics, because of their molecular structure, inherently have these multi-grade characteristics almost.
Yeah.
So you can kind of enhance them very easily with the additives to be able to achieve these. So that's one reason why they work really well.
Absolutely.
In those applications.
And you said it best. Even if you forget about a car for a second, we're working on some UTV formulas right now.
Yep.
Now, a UTV comes out of a factory, but we don't know where that UTV is going to go. Is it going to be up in the polar north? Is it going to be down
Arizona?
120
degrees last week.
Think about it. UTVs get used in all kinds of applications.
Right.
So what we want is we want to make or formulate an oil that can operate in the environment, the application that it needs. So that's kind of, I think, a good way to explain that.
And the whole reason we're going over this and beating this horse is that proper lubrication can be defined as the 4 R's. Right oil, right place, right time, or right amount. So the flow is critical to having right amount, right place, right time. So that's why understanding viscosity, choosing the right viscosity for your application is so critical. And that means for, like you said, most of the wear occurs in the engine at startup.
Yep.
So be it an overhead cam engine for camshaft wear or piston and cylinder wall wear, that's where you have to have that proper flow. So understanding the operating environment, the colder it is outside, the lower the W number needs to be in order to have that proper flow.
Correct.
So again, application dictates everything when it comes to these choices. So let's talk about zinc a little bit.
ZDP.
Right.
Yeah.
Everybody's favorite word when it comes to motor oil. ZDP. That's zinc. I need some zinc in there.
Yeah.
So what is zinc? When people talk about zinc, Tell them what the chemistry is behind it.
Well, it's actually ZDDP is a sacrificial layer. It's a heat activated sacrificial anti-wear. In the industry, we like to call it anti-wear because that's what it does.
Right.
It plates out and it prevents wear. It prevents metal contact in boundary lubrication applications.
Exactly.
So it's kind of a combination of FOS and ZDDP. That's where you get the P and the ZDDP.
Right.
And we put them together, and there's several different types. You've got your primary, your secondary, your tertiary.
Whoa. Wait, you're saying there's more than one type of zinc?
Absolutely. Because zinc, so I need heat and pressure
For it to activate. Because if it doesn't activate, not doing
anything. So when we talk about ZDDP, there's different types. And getting back to our favorite word, which is application, if your application is you need a ZDDP or you need that wear protection fast, you need an early plating versus a middle plating versus in plating's the right word, but when activation comes, you can choose different ones based on that application.
Right.
But we tend to find that we have one that works well in an engine oil application, then that's what we use.
Right.
But
so like break-in oil is a perfect example where you need that fast activation. You need it to start running now because, hey, everybody knows for, say, a flat tappet deal, you're supposed to do that 20, 30-minute break-in. Reality is, hey, most of that wear, if we're just going to live or die, it's going to happen in the first 2 minutes.
Right.
So you need to have that ZDP activating now, right off the go, in order to provide that protection. Now, flip it over to, say, a turbocharged engine, where you've got incredible turbo heat.
Right.
Now, you don't want a zinc that activates too easily with heat, because it can be consumed too quickly.
It's going to get consumed right in that turbocharger and not get to where it needs to go.
Right. So you've got to have the balance of the two. So we can make application, again, dictating chemistry. And coming back to that too, so at Total Seal, so we talk a lot about ZDDP with camshafts. Right.
And that's, if you think about the history of going back to when, the formulations were changed, the formulations were changed and the ZDDP level was lowered in what we'll call commercial off-the-shelf motors, like, motor oils. That's when you started seeing problems with camshafts and camshaft failures. So we spend a lot of time talking about ZDDP and its benefit to the camshaft. Right. However, there's other parts in an engine that need to lubricate and can benefit from ZDDP. And I think that's why we're having this conversation. One of the great things I like is, taking it away from what everybody talks about all the time or what everybody knows. And you could even educate me on this. Tell me about ZDDP with piston rings, with cylinders.
Well, think about it. Most of the cylinder wear that's ever going to occur is at the top of the cylinder,
right?
Not the middle of the cylinder. Why? That's ring reversal. So gotcha. our favorite buddy, I see if I can draw this here. I think I got enough room here to draw it up here, right? Our friend, the Strybeck curve.
Oh, yes.
Okay. So if we think about this as friction on this scale, the Strybeck curve basically takes it as viscosity times speed divided by load.
Right.
So this area up here, we call that your boundary condition. And then, so this is boundary up here, right? That's metal on metal contact, right? Bill, while I'm drawing this, why don't you explain
and
what
we're going to say
I'm going to do?
This is where we find our camshaft operating, mostly in this boundary area. So boundary is a lubrication regime that we study where you've got metal-to-metal contact, and that's where a ZDDP or an additive that's going to provide wear protection in where you've got such high pressures that you're actually squeezing that oil layer out. So the oil is not there, or it's not there in the proper amount to give you the protection you need. So that sacrificial layer of ZDDP, that's where we want it. And that's why camshafts are probably the most discussed area when it comes to talking about formulating motor oils with zinc or ZDDP.
The camshaft is going to live here.
It lives here, right. And it's not going to change out of this mixed lubrication regime or this hydrodynamic lubrication regime. The cam's going to stay here.
Yep. And that's what's cool about the piston rings. Piston rings operate in all three.
Yeah.
Because every engine cycle, it goes from stopped to fully accelerated, fast as it's going to go, back to stop again.
Right.
Every time. So it goes through all of these regimes. So think about a piston as it nears top dead center on a compression stroke. What you have is you have decreasing speed and increasing load. So you go from being in this full film at mid-stroke, you transition through mixed, and then you get into boundary condition right there, those last few degrees of rotation before top dead center.
Right.
Which is, anyone that's ever torn an engine apart and looked in the cylinders sees that wear.
Right.
So that's where
ZDDP
comes in, is your friend, because the better those rings can seal up, the more load you can put on it to make it seal, because you need gas pressure pushing the ring against the cylinder wall. That's why gas ports and pistons work so well.
Right.
So if you do anything to increase the load, it's going to increase ring seal, which is going to make the engine more efficient. But I have to balance that with the proper anti-wear additives so I don't wear the cylinder wall out.
Correct.
So I need ZDP. Piston rings need ZDP. Camshafts need ZDP. Push rod tips need ZDP.
Lash caps.
Yes.
We started talking about this morning. Let's start naming all these things that we talk about. We talk about camshafts, but what about everything else? You know?
It's way more than just lifters.
It is. It is. It absolutely is. And you come back a little bit to this 3 things everyone should know about motor oil. One of the things we should have mentioned is the internal combustion engine. It's got every lubricate. I mean, how hard is it to lubricate an internal combustion engine versus other things out in the world that CLSs that we work on? Like, you could go to steel mill and here's a bearing. And all that bearing does is spin at a constant temperature and move. So, you're worried about anti-wear. But you don't really have to worry about, fuel dilution. You don't have to worry about all the combustion byproducts getting in there. You don't go through these 3, regimes, so constantly. And so and it's outside. It's pretty much the worst environment. If you think
by
that
far.
You could create.
By far the worst environment. And think about it. How many individual components go into an engine oil versus a whey oil or a hydraulic fluid? I mean, some of them are like neat. They're like nothing in it, literally nothing.
Honestly, some of those fluids are like 99.9% base oil and 1% of this. You know? And that's all you need, because in that application, it works great, and that's all you need to have.
And some motor oils can have 14 components in them.
Or more.
Right.
And so you come back to, and we're kind of bouncing, but you're talking about additives, you're talking about ZDP, you're talking about all of these working together to make sure you've got the right amount of lubricant in your camshaft, in your cylinders. We didn't talk about hydrodynamic
bearings. I mean, that's your bearings, right?
Bearings.
That full film lubrication, that's the bearings.
Just let it spin, let the oil get up in there. Oil pump's going to give you that pressure. You're going to keep that crankshaft journal off that bearing. It's probably the easiest of the 3.
Oh, by far.
But not unimportant.
Definitely not. Because, again, with an engine, it's going to start and stop.
Absolutely.
So every time you start up, everything's over here. So you still need some additives to protect that bearing, to protect that journal as it begins to come up. And especially if you're really trying to push the performance edge of the engine, you may be right on the edge.
Absolutely.
That intermittent little bit of contact. If you don't have the right additives, it's not intermittent anymore. It's done. And
think about how much tougher it gets. We're talking about engine environments, but now you got these stop-start systems.
Yes.
You pull up in a new car to light, your car shuts off, and then you hit the, and it fires back up.
Yeah.
So it's constantly, and we already said that's kind of the worst-case scenario, right? That startup, so it's happening over and over. So all of these things, have to be taken into consideration when we do this.
Yeah. One thing you said about that, having that balance, is really key. That really is the right segue to the additive discussion.
Yeah.
Because as we discussed, as a formulator, you spend all this time thinking, trying, balancing all these different needs, from the cam to the piston rings to the bearings, everything working to get a synergy.
Yeah, right.
Well, then some guy goes to the parts store and buys this bottle of miracle stuff and dumps it in there, and I always said, it's chemical Russian roulette.
It is.
You have no idea what's going to happen.
So think about it from this perspective of all these important things. When I formulate a lubricant, the first thing I do is I take my base oils and I'm trying to get my viscosity right. And then I'm trying to balance it with this additive, that VI, so that it's going to move to where I want it. It's going to be high temperature, low temperature. Now,
back to here. Your base oil is all about
that, right?
this is additives, that's base oil. You got to make them all work.
Right.
So you got your base oil working.
You got your base oil working. Now I'm going to go to these. So what an additive, by definition, will impart a quality to an oil that it doesn't already have.
Exactly.
So I put an additive in like ZDDP because I need more anywhere. I put EP in to do a gear oil because I need extreme pressure.
Yep.
So we start taking all these things. We need detergents. We need dispersants because remember our environment in engine oil. That's the worst environment.
It's dirty.
So we need dispersants. We need to take and we need to clean up, that engine, but we also need to hold it in suspension to take it to its filter because a filter has a job to do. Let your filter do its job. And that we need to get that particulate. We need to get all that to that filter so that it can clean it out. And, it even goes beyond that, not to get too crazy, but then we have to think about how we're going to make this, like the order of operations. All of this work that goes in weeks and weeks and weeks and bench testing and testing and coming back. And we make this great oil that we feel really good about. And we go out and we test it and we see this performance and we love it. And then we find out somebody's going to just kind of dump something on top. We don't know what is in that additive package. Right. We don't know how, when we do this, we have to watch out that this additive and this additive get along, that they're compatible, and certainly having done a lot of formulations in my life, I've walked in and seen when that.
Oh yeah. One of the things I've always said
is what's at the bottom of this beaker,
this nice cloudy stuff down here.
Right. It's chemistry, and when we talk about being tribologists, tribology, we're out there looking at these surfaces and we're looking at how it works, but the chemistry is so important. All of these products have to get along. They have to solubilize together. We do a great deal of work using like esters and other solvent, because maybe this additive doesn't want to mix into the base oil. So when we do that and we put a package together, we never recommend that somebody come in with some other kind of chemistry, maybe some other technology, put it on top. Is it going to solubilize? Is it going to go in? Is it going to give you any benefit? Or is it going to detract from the performance we've already given you?
Right. Well, you said the definition of additive is something it's imparting a property that wasn't there already.
Right.
And what happens is somebody will have an experience where they say, hey, I know Bill and he used XYZ additive and he picked up 5 horsepower. Then another guy says, well, I used XYZ additive and I lost 5 main bearings.
Right.
Well, who's lying? Well, neither one of them are. The reality is in one case, the XYZ additive worked, solubilized with the base oil, the package they were already using.
Right.
It was synergistic and it gave them a benefit.
Right.
In case B, where you lost the main bearings, it didn't.
Right.
So that's the thing. You take that chance every time you buy a bottle of additive. I'm sure you agree with this, is that if you feel like you need to add something to your motor oil, it means you have the wrong motor oil.
Yeah, get another motor oil.
Right.
Get a motor oil that is formulated for your application.
And it'll work better, be more consistent. And even if you got a package that's working for you, the reality is standards change.
Absolutely.
And it's next time you go to the store and buy that oil, it may not be the same stuff. Could be the same brand, could have the same viscosity and all that, but if the little numbers in the back change from an API-SN to an API-SP, for example, it may not be the same stuff in the bottle anymore.
Absolutely, and that's in diesel oils too.
Right.
Same thing,
It's not saying those are bad.
No.
Saying they have to change to keep up with the spec. So that's just part of what that game is. So in a high-performance application, you have to be aware of these things, which is why we're doing this. So we're not trying to scare anybody. We're just saying, hey, here's the things you need to know and be aware of so you can make good decisions about which oil to buy, how to take care of your stuff, so that you've got good, solid advice from two tribologists are telling to you. So,
And, and even coming back to the additive point, too, we talked about with ZDDP. So if I use this much ZDDP and I got all this benefit, man, look at this benefit I got, my camshaft, and, I should just put more in. So if this much is good, then maybe twice as much.
Thank you for bringing that up. Yeah, more is not better.
No, you actually go the other way.
Yes.
So there's a point where ZDDP is giving you all this wonderful, sacrificial layer, and it's doing all this stuff, and it's giving you this great wear protection. But then there's a point where it's actually going to go the other way.
Yep.
And it's going to do the reverse because it is actually plating out, and there's too much of it, which goes back to when we talk about balance too. Remember, these additives, we talked about detergents and dispersants. So we have to be careful when we're formulating an oil with ZDP to give you the protection you need in your application, that we don't have too much detergency, or else what's going to happen?
It's going to compete against it, wipe it all out.
Right. Yep. And going back to those additives, we take a lot of time in focusing and learning about that and making sure that we have that correct.
Yep.
Top treating takes that all out.
Exactly.
So
anyway, hope you guys have enjoyed this segment and have learned something. Bill, if they have any questions, how can they reach out and get hold of you?
You can go to our website. You can find our phone number there. You can email balexander@drivenracingoils.com. We encourage everybody to call and ask questions. We're here to answer questions, and we love talking to everybody. So please give us a call.
Thanks, man. I appreciate you taking the time to be here. And so back to you, Joe.
Yes.
Well, he was definitely not an oil person.
Definitely not.
But he brought some good thoughts to the table, and we developed some good technology at the time, and I think we fundamentally changed how you look at oil 22 years ago.
Yes, sir, we did.
And maybe no preconceived notions, right? You could just mold him into whatever you wanted him to be.
Well, I don't know.
He doesn't want to take the blame for that.
Not taking credit.
He may have broken that mold, by the way.
He may have, yeah.
Now,
Nature versus nurture.
now, before we go too far, though, we did have a question out there that we wanted you to answer. It is on the subject, and it was like, why is it bad about running break-in additives at the time, according to manufacturer's directions? I'm running a flat tappet setup, air-cooled, smaller power plant. Can you
Real simple. Anytime you add an additive to an oil, he can answer it better than I can, but anytime you add an additive to an oil, you're playing chemical Russian roulette. You really don't know what type of ZDP is actually in the oil you're using versus what you're adding to it. And they can clash. So mixing it properly can be a challenge, and so because the base oil you're using all the time can change. Formulations change, the specifications evolve, so it may not do tomorrow what it was doing today. So you really don't want to use an additive ever, actually, even during break-in, because it's playing chemical Russian roulette. If you need an oil that has the proper level of ZDP, as we were just mentioning, we changed that world 22 years ago. There's lots of oils available today that are application specific. Thinking back to what Freddie Terza said earlier, that are available for your engine that will do a much better job than trying to play chemist by mixing your own stuff together.
Isn't it also a case where a lot of times with that chemistry, and certain ones of those more isn't necessarily better?
Very true.
Yes.
I mean, the additives and the oil compete with each other for the surfaces of the metal. Right, your zinc's going to compete with the detergent, friction modifier. So if you overload the oil with certain additives, they're going to sort of shut out the other additives that need to operate as well. Too much zinc is going to create problems for the detergent as well as any friction modifiers that may be in there.
There you go.
And oil formulating, as Lake talked about in the previous session, is a highly technical field.
Right.
I think you mentioned in the video prior to this that formulations may take 14 components.
Yep.
Today, they're upwards of 20 to 25 components. Individual components down to the 0.01% level.
0.01%. That's like next to nothing.
Right. So it's a very technical area. You start adding things to your oil, you're going to change the balance of the chemistry and the functionality of that oil, pretty much.
See, that's why I wanted him on the panel.
There you go. But this particular panel is not necessarily about oil, but it's a part of the overall thing. We're going to talk measuring,
right? And in fact, one of the first trips I ever went on with Mike was we went to Lubrizol's lab in the UK, at Hazelwood, right? And because Mike was in charge of blend test services for Lubrizol globally. So like Keith mentioned in the previous hidden horsepower deal, when they got that big horsepower gain, what's the first thing he did? We went and recalibrated his dyno to make sure he wasn't off. That was cognizant of, hey, I got to make sure that my measurements are accurate. When you're measuring components, 25 components at 0.01%, you have to have accuracy and precision, which this man probably knows more about all this than the rest of us combined. But I think that's why we wanted to have this measurement roundtable to talk about why is it important to make sure that you're accurate and repeatable in your measurements and calibration. I mean, I think about Billy, the profilometer there in Memphis. Why was that table set up the way that it was?
Yeah, I mean, when you get down to measurement, I'm probably jumping ahead, but whatever you want to be able to measure to hold a tolerance to, the rule of thumb is you want to be able to measure 10 times better than that. So if we wanted to make a speck at 10 millionths of an inch, we need to be able to measure at 1 millionth of an inch. And when you start thinking about what it takes to measure down in that 1-2 millionths of an inch, any vibrations, almost anything that you can imagine, you can't touch the table while we're running a profilometer test.
Right.
Because you will see this blip on our screen that looks like an earthquake happened, just from simply laying your hand on the table.
Right.
And you've been back there between me, and I've been like, don't touch it. And you're like leaning toward it, I'm going to slap you. And it's like, because if you have to repeat the test, but
and there's trains that come by
story
too.
That you tell about Scooter Brothers, and you were trying to convince them to buy this cam grinder. He's going, no, we need to be an ADCOL, because if we can't measure it and we can't, manage what we're doing, what good is it going to do us to have a better cam grinder? Yeah, what do we say? There's the scientific definition of trying to manufacture something better than you can measure it. I think the technical term is a guess. So, and that's one of the things that Scooter was like, Billy, you can't try to make ball bearings and measure them with wood calipers. If you're going to have your measuring equipment, you can never do better with your manufacturing equipment than you can do with your measuring equipment. So anything that, if you got target shooting, if you can't see your target, you're never going to get a bullseye. If you do, it's 1 in a million. It's luck.
It's just luck, right? It's just luck, yeah.
But when you can actually see what you're aiming at and focus on that, and then know that you trust your data, then you can start making process changes and really seeing what they did. The first week we got our ADCOL gauges in, we didn't ship camshafts for an entire week because we got this measurement device in and we kind of freaked out, right? And it's sort of this panic thing when you get to measure something good. But
it's kind of like Brad's piston measuring tool.
Yeah.
It's like, oh God, nothing's good.
No, right. You just look at it, you just scream and you run out the door. It's kind of like a horror movie. But after a while, you start looking at it, and then you can make process changes, and you can see things. Like, we never thought a Burco grinder was able to hold more than about a ½ degree on angle. But once we had something that can measure down to a 10,000th of a degree, you go, oh yeah, you can hold a 10th of a degree, no problem. And you're like, well, you can't do it without being able to measure it, though.
Right. And I think about some of the testing stuff that Doug did, and with the Lubrizol. Talk, Michael, some of the equipment you guys had in the lab. Because that first time going to Hazelwood, it was like mind blowing to me, the breadth of testing equipment. I mean, CMMs that were bigger than this table.
Yeah. There's technology out there that can measure down to basically whatever you need to, but you got to know where to look and find it. And the surface technology that we had capabilities and analysis capabilities were, things that pointed us to some flaws in the cams and the lifters.
The coatings, the DLC coatings. We would send you coatings, and you guys had a scanning electron microscope, if I'm remembering right, that could actually see the sections and the layers of the DLC.
Into the DLC and see if there were any flaws, sure. So it's the technology is there to measure it, but you've got to be able to measure it properly.
I mean, even the whole conversation of measuring stuff properly, this came up, you and I were talking the other day, and trying to decide, how do some of these segments go, and there was one about testing and data collection, and there was one about measurement, and how should we lay out the seminar, and as we talked about, it's like, well,
you almost have to talk about measurement first, because what good would it do you to be testing on the dyno or the flow bench or whatever thing you're measuring, or you're collecting data with, if you haven't properly calibrated it and been able to measure repeatable, and reproducible. Chuck, you talk about that a lot, so it was a no-brainer to talk about measurement and what to measure, how to measure it, what are we even trying to keep track of before you even bother about collecting data that may or may not be valid.
But it's an easy way to lie to yourself.
Yeah, absolutely. And you made the comment about the ADCO. I felt the same way when I got the microscope. It was like every part in my shop was junk all of a sudden.
I think I sent you a message about you're going to freak out as
yes,
you look
you
at
did.
this. You look at the end of a needle on a microscope and see a burr, and like, wow, doctors stick that in. You inspect all of these different things, and it's terrifying. You think nothing about it until you look at it, and you don't know what you don't know until you know, and then you can never go back.
You can't unsee it, right? You can't unlearn that. So.
Right. Wow. So talk about the gauge and measurement and precision, because I know that was a big part of what you were doing in your earlier career.
Right, and actually, I did an article talking about the 10 to 1 rule. I mean, there has to be standards. In qualifying parts, that's one of the things they always, okay, first I need to know the critical quality checkpoints, and then what those standards are, and then, okay, what gauging do I need to measure it? And then you have to think about the calibration of said gauges, and that they're giving you reliable information. And, you've got ISO standards and things of that nature, but we typically, we look at NIST, National Institute for Standard and Testing. Those things are very important, because if you don't keep your measurement equipment calibrated, it's no better than guessing, really. And across our industry, that's something you preach often, because if you're going to pass it on to the next guy, well, he needs to know that he can look at the critical to quality features and that the measurements can align, or else it's finger pointing arguments, he said, she said, all the time.
Well, we've talked a bunch, like in our group, even with Chuck, about just something simple like a torque wrench. How many guys have a torque wrench that's been laying around the shop for 20 years, dropped on the floor, and they've never really rechecked it, And I think, what were you saying was the standard when you were at Jasper, how often you guys recalibrated those or checked them?
So they get certified like monthly, but they have the opportunity to check them daily. Anyone that gets bumped, they get stations set up everywhere. But like, the click type wrenches, I mean, they're only about 7% accurate.
7%.
Imagine that,
Yeah.
7%.
And then you do things like leave them loaded with they get the spring there.
Yep.
And then you compress the spring. It takes a set. There's a little block in there that gets you the audible click. Well, you use that a bunch of times. You cycle it. Well, the nice sharp square edges are now radiused over. So, I mean, so many factors for every action. There's a reaction, and
even down to, you were talking about how much inertia, how much swing the guy would have on the torque wrench, right? Like, you can absolutely change the value of torque that you get with the wrench if you go really slow or really fast. And so, didn't you say you had like a contest you were doing or something, or you would like have different guys do it and they were surprised by it?
Oh yeah, like you put them on the calibration thing. You got like the wine press, and you bring them to calibration. Well, no one ever does that when they're assembling anything, and absolutely amazing. Like I said, we just line people up. Okay, so you turn bolts all day, every day, and so they'll go through the process of trying to hit the number. Okay, this thing is supposed to torque at 65 foot-pounds, and the scatter, that we refer to was just amazing. And so people would go back out on the floor, and now they're almost timid because, man, I've seen all crazy amounts of scatter. But everybody does the wind up pull, and then they listen for that audible click, and then they do this thing click click just to make sure that it clicked. Right. And then, we're now at 75 foot-pounds instead of 65.
3 Ugga Duggas.
Yes.
So in a couple of words, we've got a couple of minutes remaining here in the roundtable, and I'd like to hear from each of you just a thought on best practices for people out there. Best practices, either does that apply to your equipment, your tools, like how to keep them, how to maintain them, how often to maintain them, how to use them. I'd love to hear a thought from each of you, starting with you, Chuck.
Right. Cleanliness, all that grit and everything can really impact the quality of the tools, whether it's a dial indicator, calipers, things of that nature. So cleanliness, storage, and definitely practice some calibration standards. Get on a routine, whether you manage it yourself or you have an outside. There's a lot of outside calibration companies, and they'll remind you. Of course, they want to get paid, but hey, they're going to put you on their calendar and they're going to tell you need to get this part calibrated, this part calibrated. So, keep the stuff in good working order.
Those companies save you money over time.
Yeah, absolutely. Yeah. I think, Joe, some of it is just being, as a normal shop, there's a big difference between like something like the facility Mike has available or maybe Billy and like say a regular engine shop. It's just not quite that level of technology and equipment, but so much of it is the willingness to be honest with yourself about what is it that I actually have here that I believe in. I know you love WJ quotes, so one of the things that Warren would always say is, well, you're checking that with a straight edge. So how straight is your straight edge? You got to be willing to ask yourself, is this thing that I have as precise or accurate as I think, and go, okay, so then what would I need to do to check that, calibrate it, clean it, service and maintain? But so often we just get lulled into this sense of complacency, and you put the wrench over on the box or the flow bench doesn't get calibrated or whatever. But I always say, when you're on the dyno and you run an engine and it puts up a big number, everybody just high fives and you go home.
Right.
You never question whether that was accurate, right?
No.
And the thing doesn't make a number. You're like, oh man, something's wrong.
No, exactly.
This dyno, So I think a lot of it is a mindset of like having, like you said, just a regimen of regular testing and calibration and like the willingness to question everything.
Excellent. Billy?
Boy, I shouldn't say this, but I think the first thing that people need to be able to do is do some real serious failure analysis. Because when you're thinking about what you need to check, until you start seeing parts that fail, whether it's from motor oil, whether it's from not torquing a gasket enough, you start looking at it and go, okay, what is the real root cause? And back to your deal, you have to really think about this root cause. When we see a failure, we're looking at it under the profilometer, we're looking at it under the microscope, we're doing acid tests, we're doing sections, we're doing everything we can to let this failure tell us as much as it possibly can. And then you can use that failure analysis. Once you understand the root cause of your problem, then it lets you go back to your measurements tools. One of the things that's maybe as simple, like you're talking about, simple as checking lash. People check lash all the time, but every engine builder does it a little bit differently. Sure. So maybe you need something set up that's welded together over here that you guys go, okay, this is what we call a 15 lash. And everybody feels that, and you have a thing, and you get it, and you recalibrate yourself and make sure you're getting a good measurement, because figure out, okay, what caused my problem? Well, this lash caused my problem. This lash got too much. Okay, so how can we improve this technique? Without failure analysis, you're tempted to get in to measuring for the sake of measuring, not measuring for the sake of making things better.
Right. Excellent. Mike?
I would say that in terms of calibration on your measurements, definitely keep a log, an ongoing log. Do a trend line, trend analysis to see if things are drifting up or down. And invest in some standards, some known standards that can help calibrate your equipment, because without a known standard, you might just be flying blind in many cases.
And that's something we come across all the time, actually. On a daily basis at Total Seal, we're asking people to measure depths of ring grooves. Because sometimes you have a piston spec sheet will give you that information, but a lot of times you rebuild an engine, you don't have that. So if your vernier scale caliper isn't calibrated, it's not giving the right number, then you're not going to give us the right number, which means we're not going to give you the right size ring, which means you're going to end up with a failure, and you're like, well, those things are junk. Well, no, they're not junk. It's just that we didn't have the proper measurements to begin with, so it's critical to have that. So just one of those little things that sounds big picture, But in reality, it's very practical and a daily thing that needs to be done.
Easy to do.
Yeah.
Gentlemen, great job. Appreciate it. These round tables, they're my favorite.
Awesome. And we're going to be back later to
Yes.
talk about testing. It's going to be fantastic.
Testing, exactly. But coming up next,
Mechanical fuel injection with my favorite person on the whole world. And I say that about everybody, but I have lots of favorites, right? Everyone's favorite.
Ronnie's a good choice, though.
Ronnie's, yeah. This is my other dad, Ron Schaefer, talking about mechanical fuel injection.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.